So just a very quick video. On the bench here we've got this Harman Kardon Bluetooth speaker. It's completely dead, does not want to turn on. Connecting the charger, it also does not want to charge the batteries anymore. So let's have a look and see what we can see inside. There are 4 screws here, here, and over here. They are underneath these little rubber inserts. So you just have to pull them out and take the screws out there, and then you basically just have to take a spudger, plastic one preferably, and start prying away at the seam here. And it's got a whole bunch of different hooks that you have to pry open. And then just do the same for the other side. You can see they've got these rubbery compliant little inserts. And now you'll see at the bottom you have a whole bunch of additional screws that have to be undone. Okay, and now this should just pull out. So right in there, we've got one more sneaky little screw. And now finally, we should be able to open this thing up. Now I don't want to risk damaging this battery, so I think I'm going to try and see if we can open up this shell further to see what's on the inside here. Now it would seem that under these little rubber inserts that you have here, you have actually even more screws. Oh, as you can see, that took quite a bit of effort, and of course all the time you have to be very careful not to damage any of these subwoofers or these tweeters that you see here and here. So yeah, just be very, very careful. Yeah, it's like a wasteland of screws and rubber inserts. But of course, all of these screws are there to prevent vibration in the case. This has quite a lot of bass. These kinds of cases will very quickly rip themselves apart if they're not screwed down or held down. Now that we've got all the screws out, we should be able to pry this front part open and separate it from the rest of the case. Oh yeah, there we go. Okay, so there are a few connectors that we have to undo. I'm not sure if you can see that connector right over there. That's one that we have to disconnect. And then right next to it, we have the Bluetooth antenna cable. So that connector over there and the Bluetooth antenna cable have to be disconnected. Now this really is quite fiddly. It's very difficult to get this Bluetooth cable disconnected here. It's got a tiny UFL connector, which I don't want to undo on that side. But at least we have access to this battery compartment now. So we have to disconnect the battery over here, and let's see if we can just push out the battery from the back. This is in there so tightly, really pressed into this cavity here. Okay, this battery is not budging from this cavity here, and I think to get it out it's going to have to be a bit destructive on this battery. But what we are interested in is to measure the output voltage on this battery, just to see if it's a problem with the battery or whether or not it's maybe a problem with something else inside the speaker with the charging circuit. So let's measure this first. Is that completely dead? Is that like a dead short? Now I have read that these batteries sometimes go into a mode where they shut down completely, and they just need a sort of a charge on these points between negative and positive to activate them again. So let's do that. I'm going to connect my bench power supply at 7.2 volts onto these two poles, and just see if we can revive this battery. Okay, just hook the negative my power supply here. Just going to put the positive on there. Right, it's drawing about 30 milliamps from the bench power supply. Just going to disconnect it now. And now let's measure the voltage across here again. And there you can see 7.2 volts. Now this is probably due to the way that the battery management circuit inside this battery works, and if it discharges too far, the battery management circuit shuts it down completely, and there's no way to reactivate it other than taking the whole thing apart and connecting a 7.2 volt voltage source to the battery for a short while. Alright, now the question is, will it turn on? And it does. There you can hear the startup tune, and it's synced to my phone. Very nice. You can see the one little LED burning. That's the battery strength indicator, so the battery needs some charging, but that is a fix. Well, just a few short days later, and here we are in that same state again. The Harman Kardon Bluetooth speaker is not switching on, and I suspect when we measure the battery pack inside, we will again see that it is at 0 volts. So perhaps there's something that we need to do about that battery pack. And let's just quickly have a look what this reading is. And there you can see 0 volts as we suspected. Right, so we need to get this battery pack out. Now it looks like there's a shaft coming from the front that holds this battery pack onto the chassis here. And indeed, if I take out this little rubber piece here, there's a screw deeply recessed. Same for the other side, so we'll just have to undo that and get that battery pack out. Right, now we've got the battery pack separate from the main chassis. You can see it's extremely well padded to prevent any rattles from occurring inside the chassis. But yeah, now we should be able to remove this battery pack. And the thing that we want to see is whether or not this battery pack has its own protection circuitry and charger in, or whether or not that is on board. So let's get this pack out. Okay, so it definitely appears as if this battery pack is sort of self-contained. It has this charging board here, So likely already does the balancing as well as the charging and the protection. So we might have to either salvage this board or replace it with something of a similar function. Now the pack itself seems to be just two of these lithium ion polymer batteries. You can maybe have a look at them and see if there's any capacities on them, but they do appear to be quite puffy. Okay, so no markings on them, but they just do appear to be just soldered to the bottom of this board. I'm not sure if that's in parallel. We'll have a look. It probably will be parallel series, because previously this pack did measure around 7.2 volts. So let's try and get this board off. Yeah, so these are definitely appear to be in series. At the bottom, these two are connected together, and at the top they're connected directly to the output, but they do have a tap in the center at the bottom, which is probably there for the battery management. And there is a tiny bit of text, I don't know if you can see that, over there, that says BM, probably for battery management. So we might be able to reuse this little board and make up a new battery pack for ourselves, but we'll have to see if we can fit it in to this container over here. Okay, so I want to show you something. If I measure across the actual battery poles, you can see 7 volts, but if we measure across these output points over here, you can see immediately goes back to 0. So this control circuit on this little board is for some reason cutting off the output. So let's just see why that is, and I think I know why. So if we measure, this is the sort of the common point, so we'll be measuring the one battery, and there you can see 4 volts, which is fairly high. And if we measure across the other battery, you can see 2.9 volts. So that is likely why the circuit is cutting it off, because the batteries are no longer balanced. And you can actually see the one that I'm measuring now is the one on the left, this one here. And that is definitely the one that is thicker and more puffed up. So perhaps it's a good thing that the control circuit is cutting off that output. And you can see I've scratched off this foam here. So it's 7.4 volts, 3000 milliamp hours from great power. I think that's more like not so great power. And of course made in China. Okay, so I definitely want to replace this battery pack, but I don't think I'm going to replace it with a similar shaped lithium ion polymer battery. Let's see what else we have. Okay, and just trying to form an idea of what kind of batteries we might be able to use to replace this pack. You can see here I've just got normal 18650s, and that's going to be too large. So we might have to look for something a little bit different to see if we can fit it in here. So I've had a variety of projects brewing on my bench here, all the way from just renewing a normal drill pack to creating some backup light solutions. And I have a few of these battery packs now. These are your normal 18650 batteries. They're made by Samsung, but they are 2900 milliamp hours, and ideally I would like to have more capacity rather than less. So the question probably comes down to, Do we go with short and fat, like these yellowy green ones, which are 26650s, 5000 milliamp hour each, or these 21700s, which are also 5000 milliamp hour each? So yeah, I think any one of these pairs would work. We can I think the deciding factor would probably be what space we have inside the enclosure. So let's go and do some tests. Okay, so I'm probably not going to stick anything inside this old enclosure here. Just going to screw it back into the chassis there, and yeah, that space will no longer be used. But I think we can fit these batteries in on the sides of this passive element there. So maybe something like that. So we just have to make sure that none of this sticks out and maybe presses against the electronics on the other side of this chassis. But I think this will fit nicely. So let's just quickly take a look at the thinner but longer ones. So yeah, once again, that's not a bad fit. I don't see any real difference between the two. Maybe that will be a little bit of a better fit. Yeah, definitely. That is definitely, I think, the pair that we will use. So this battery we will no longer use, but we will definitely desolder this little charger board. That should still work nicely, and then just integrate them into these two batteries. Now at this point it's probably a good idea to actually cut these cells loose, because one of these cells, this one, still has a good charge. Definitely over here you can see the other cell, the one with the low voltage, almost looks like it's leaking. Yeah, we'll have a closer look at that maybe later. So let me take my side cutters here, the ones that I don't care too much for. Let's just cut that out. Oh, these are actually quite soft, these connections. Wow. There we go. Now I think we should be able to just desolder this. Give it a good clean, get all that flux off. Now on these battery holders, I just want to actually bend these little connectors or tabs out, sort of turn them into surface mount battery holders. There we go. Same for this one here. Nice. Okay. Now I should be able to flushly glue this down on the inside of the chassis. I think I'll roughen this up a little bit with some sandpaper, and it'll be ready for gluing. The way that we want to connect this, we've got the balance, the battery management balancing point over here, and that will be connected to this pole and this pole over here, and they will be connected together. And then we have the battery minus terminal over here that goes to the negative terminal on this battery holder, and B plus which goes to the positive terminal on this side. I've got this wiring loom from an old PC power supply. I think we can salvage some really nice and thick cabling from here. And we'll just add a generous dab of flux. Nice and shiny. Okay, and there we have our balanced butterfly. That should fit in nicely. Now all I have to do is just glue it in. Now one thing I quickly want to show you here, if we measure over the two cells, you can see that's 7.14 volts, and these wires run to the underside of this PCB. But if we measure on the top here, the output of this circuit, you can see it's still 0 volts. So I suspect what we'll have to do, because these are now balanced. I mean, if I measure that one, that's 3.5, and over here, that's 3.5. So I suspect we'll just have to enable this circuit again by just jump starting it quickly with a 7 volt load. Let's just quickly see if that does the trick. Right, so I've got my power supply set to 7 volts. I've just got the current limit set to 100 milliamps. Let's just quickly see if we inject this here now. Okay, nothing's happening in the supply. Now let's measure this again. Hey presto, there we go. 7.14 volts, which is exactly, well, more or less exactly what we have there. And here we are. You can see it's now fully charged, and it has cut off at 4.209 volts, and that is of course almost exactly the voltage that it should cut off at. So it's not overcharging these batteries. The internal battery charger of this Harman Kardon speaker is still 100% functional. Let's just turn it on, and you can see all the LED indicators fully functional, and the battery indicator showing that the battery is nice and full. Right, now once again to reassemble this thing. So when you're bonding plastics, it's always very important to just rough up the surfaces a bit, just so that it can bite into that plastic and bond a lot better. And of course, just make sure the surfaces are completely clear of any dust. You can even give them a bit of a clean with some alcohol, just to completely remove all the greasiness or anything like that. Alright, and these now should just bond directly in to these two spots. This is always a very fiddly exercise, because the moment it makes contact, that's where it sits. Yeah, okay, that I think that's good enough. It's really tight in there now. It's not going anywhere. So yeah, happy with that. And there we go. Yeah, that's nice and neat. It's a good fit, and I think that'll work just fine. Okay, so again, I think we're at the point where we can now assemble this Harman Kardon enclosure again, and hopefully this time the battery will last quite a bit longer than before. I've seen so many videos on the internet just showing how to replace the battery, or maybe to reinvigorate the battery by jump starting it with about 7.2 volts. It appears that the great power battery is not such a great quality after all, so hopefully these batteries last quite a bit longer. And just for those keeping count at home, I've done a quick screw audit here, and we have 22 screws of this size that sort of keeps the chassis together. Then we have 12 of these screws. They are screwed into the bottom of this plate right around the edge, and it appears that we have a rogue screw here. This screw doesn't have a position anywhere in this chassis, so I suspect maybe this came from one of my other projects. And of course then the 12 rubber inserts, and 3 of the feet. The fourth foot is actually integrated into the bottom plate here as this part. Okay, so let's start reassembling. Now I wanted to make sure that we test these woofers with quite a lot of displacement, just to make sure that there aren't any rattles left in the case and that all the screws are in tight enough, and it looks to be the case. Okay, I've got the studio lights turned off. Let's switch it on one final time. Perfect. Sync to my phone, Bluetooth is working, the battery is now fully charged, and yeah, it seems to be fully functional again. So guys, I hope you enjoyed the repair and sort of a restoration and improvement of this Harman Kardon Bluetooth speaker. If you enjoyed it, please give me a nice big thumbs up, and I'll continue making these videos. Thank you for watching.